Okay, so one more type of question when it comes to substitution rule for integrals is how to actually evaluate definite integrals using the substitution rule. When we do that, we actually have an extra step. So first of all, our upper and lower limits are always used in terms of x. Now, when we implement in terms of u, we actually have to evaluate the u function at a and b, and that's going to give us new parameters, new upper and lower limits. So let's see that happen with this question here. So first of all, right off the bat, it's really hard to integrate this. So I'm going to use substitution. Now I'm going to let u be equal to x cubed plus 1. And the reason why I chose that is because if I take the derivative, I get 3x squared, which is going to be the same degree as my numerator. So I can actually try to cancel that out or rewrite it in terms of u if that's the case. So what I'm going to get here is from 0 to 1. However, it's not 0 anymore and it's not 1 anymore. I actually have to evaluate my u function at 0 and my u function at 1. So I am changing my lower and upper limits because I'm using substitution rule. Then I'm going to have 2x squared on the top and then x cubed plus 1. Well, that's just u now. So I somehow need to rewrite x squared dx or 2x squared dx in terms of u instead. So going back to u is equal to x cubed plus 1, I'm going to take the derivative. I get du dx is equal to 3x squared. And I actually can see that I can get dx times x squared in here by taking dx and bringing it to the other side. So du is equal to 3x squared times dx. Therefore, x squared times dx is just going to give me du over 3. So there is the substitution that I'm looking for to rewrite everything in terms of u. So first of all, I'm going to actually find my u values, my new lower and upper limits. So at u of 0, I'm going to take my u function, which is x cubed plus 1. I'm going to put 0 instead. So I get 0 cubed plus 1 gives you 1. And then I'm going to evaluate again at u when x is equal to 1. So I get 1 cubed plus 1 will give you a new value of 2. So my lower limit is now 1, and my upper limit is now 2. Okay, so I changed the values now so that everything's in terms of u, including the lower and upper limit. So now I'm going to get 2 over u, and then x squared times dx is really du over 3, according to our substitution over there. So before I even take the antiderivative, I'm going to rewrite this as follows here. I'm going to go 2/3 and then 1 over u. And then, of course, this is all being we're all integrating with respect to du. Okay, so I'm just going to split it up. Now, when we take the integral, the 2/3 is just going to stay where it is. That doesn't affect anything. But 1 over u has its own antiderivative, and the antiderivative of 1 over u is ln of u. And of course, we're going to add, we're not going to add a c value because we're doing a definite integral. So ln of u, and we're going to integrate from 1 to 2. So we now just put in our values. So 2 over 3, ln of the u value, which is 2, and then we're going to subtract 2/3 times the ln of 1. Now, this is what my answer is going to look like. Notice the ln of 1 is going to be 0. Okay, so this is all going to be 0. So my answer is going to be 2/3 times the ln of 2, and as an exact value, that's how you do that question.